Hello, everyone, and welcome to our talk where we'll be explaining systematic reviews in 15 minutes. I'm Michael, and I'm here with Rishi. We're the ophthalmology presidents this year, and we'll just jump right into it.
Sure. So why us? Well, obviously we're not academics, but Michael and I have both done a systematic review before. We both presented internationally, and I've published one already. We're both working on another one now. So whilst we're not experts, we have done it before, and we hope to tell you how to do it as well. Okay, so why do a systematic review? Well, a systematic review looks at different clinical trials for one treatment and sort of compares them together, whether they're saying the sort of the same message. Why would you do one? Well, it's useful for your portfolio. Every medical specialty really likes the fact if you've done a systematic review. Another underrated benefit is that it's independent. It's within your control. If you've done primary research before, you know that it's all within the control of your supervisor. And therefore, if they have any delays or they don't get back to you, you won't get any output. Systematic review will take as long as you put your time into it. It's known to be a really high standard of research, and therefore it's relatively more likely to publish and present. If anything we tell you today intimidates you, you could also consider a literature review, which does the same sort of thing but has a less robust methodology, so it tends to be a little bit easier. Okay, so how do you find a topic? Well, lots of people look into journals like the ones pasted on there. You can find new treatments that are exciting, that interest you. But what I would say is be careful to make sure that there's enough literature before you start a systematic review. Another way you could go about this is by looking at existing systematic reviews that are 10 years old or even older. This is because these topics might have had more literature come out since the systematic review was published, and therefore you could redo it and maybe even find a different conclusion. So we're not just going to search for any treatment, any condition, we're going to have a really thorough search string. And this is because terms, words, conditions, they can have synonyms. Take artificial intelligence, for example. Whilst it's slightly different from its synonyms, the word can be used interchangeably with machine learning, neural networks, or even support vector machines. You want to make sure that what you're searching for is as robust as possible so that you see every single paper. Now, this looks really long and confusing, but if you actually separate the terminologies, the ands and the ors and the brackets, actually tends to make sense. Have a look at the syntax and have a look at the mesh terms, and this can help you make a really good search string. So we're not just going to put this into Google, we're going to be putting these into medical databases which publish peer-reviewed literature, which are more accurate. You should use ideally all of these databases here. So once we search for them, that's great. We might have 200 of those in PubMed, a few hundred in Embase, etc., etc. What are we going to do with them? Well, we're going to use Covidence. Covidence is essentially the one platform for systematic reviews. You get free access through your Imperial email, and other universities will have access as well. And what you need to do is upload your references. So once you've searched into these databases, there'll usually be a button that says export or download, or even send to. You need to click that button and download the file onto your computer, and then upload them or import them into Covidence. Covidence is really good because it takes out the duplicates automatically between the databases, as you can see here. We'll talk about what to do next with Covidence, but I also want to highlight Prospero. Prospero is this registry for data systematic reviews. And you can see what systematic reviews are currently being worked on. And you can also claim your idea if you fill out their form, which will take roughly 3 hours. It's not an essential step, but I highly recommend it because the systematic reviews I've been a part of that started but never finished were because the initial stages, especially the planning, were not well done. You can scan this QR code to see an example of a Prospero, but I'll also just take you through one now. Okay, so this is what a published Prospero looks like. You'll need to give some basic details and some your search strategy, but I want to focus on the eligibility criteria, also known as your inclusion and exclusion criteria. You should follow a PICO method, population, intervention, comparator, and outcome. You want to really clearly define who you're investigating, what age these patients are, what condition, and what cause. You want to clearly define the intervention, as well as the comparator, which is usually the gold standard. But this is the bit that I think is the most important, which is your outcomes to be analyzed. You want to define your primary outcome and your secondary outcome before you even start your systematic review. This is so that when you get to the data analysis stage, you know what you're looking for. You don't want to just choose some papers and then decide, what data do I have to analyze? You want to do this well in advance. You need to give a little bit of information on what you're going to do for data extraction and risk of bias, which we'll talk about later. Then you submit this form. Okay, so let's go back to the presentation. Great, so let's go back to Covidence. At this stage, we've uploaded all of our references. We've got a lot of papers. You might have a few hundred, you might have a few thousand. So you need to screen these because you're not going to use all of those papers. A lot of them aren't even going to be relevant. So there's two stages you can do. You can do abstract screening and then you can do full text screening. Abstract screening, you're just going to look at the title and the abstract, which is automatically uploaded onto Covidence, and you're going to decide whether to include or exclude it. All you're looking for is whether this relates to your topic. This is because that when we were doing our ophthalmology paper, we were getting some random search results on train tracks or semiconductors. This is just because databases can be weird sometimes, so you're just trying to filter out all of those. After this, you do full text screening, and this is where you click this link here and you'll go to the full paper and you're going to be reading through it. You're reading through it to make sure that it matches your inclusion and exclusion criteria, but also critically has the main outcomes that you want to analyze. Once you've done all of this, you've got the number of studies left, which are going to be included in your meta-analysis if you choose to do one. There's no exact number on how many this should be, less than 10, and you probably are going to be jumping to conclusions, which might not be very accurate. And more than 30 might mean you have a lot of work to do. But this is really going to depend on the extent or how well this topic has been searched. Just to wrap this part up, I want to make it really clear that it's easier to do a systematic review if you have a very clearly defined structure. For example, treatment A versus treatment B in this condition with this primary outcome. That will make your life easier when you're doing data analysis.
So after you finish your screening, you then want to move on to data collection and data analysis. When collecting your data, essentially, you usually just get the mean and standard deviations for whatever your primary and secondary outcomes are. Primary outcome being the main goal of your study, and secondary outcomes usually being other relevant pieces of data that might also be interesting to look at, but perhaps aren't as important as your primary outcome. And when you're having a look at your data, you essentially want to just start with basic descriptive statistics, looking at the distribution of the data, what does that tell you, general trends. And then if you want to take it further, you can then actually look at a meta-analysis, as Rishi mentioned. This essentially boils down to creating a forest plot, which shows you the effect size, as well as the general overall effect and weighting of each study, and as a result can calculate the general effect of the intervention that you're looking at. To do this, you can use the Cochrane RevMan software. This is a website you can find online. However, this does cost money, so you can use a free trial for it, but it'll only be for 1 month, so bear that in mind. If you know coding or are happy to learn a bit, RStudio has a good package called Metaphor, which you can use for also creating these meta-analyses, forest plots. However, again, this requires a bit of knowledge. So if you're happy to learn, it's quite a useful skill for the future. And after you finish with data analysis, it's actually worth writing up your abstract. It's a bit of a strange order, I know, but actually, essentially at this point in time, you will have collected all your data and analyzed it, and that means you'll actually have the bulk of what you need to actually write up your entire paper. And as a result, you can actually write up your abstract at this point in time. The reason you want to do this, though, being that a lot of conferences will have their deadlines for abstract submissions, and so you want to make sure you get your abstract in time. So the sooner you do it, the better. And in the meantime, while you're waiting to hear back from these conferences, you can then write up the rest of your paper, as you want to kind of maximize the number of presentations that you can do, if possible. And then the general format for abstract writing, we'll look at the introduction first, which gives a general overview of either the background of the condition or whatever you're covering in your review, as well as perhaps why what you're doing is important and what the aims of your study are. You then go on to the methods, which describes what databases you used and also talks about your search process, such as inclusion exclusion criteria, and also what statistical tests you used during the data analysis part. Your results are pretty self-explanatory. They'll cover what your primary and secondary outcomes, what you found with it. And then you'll end off with a conclusion, which generally summarizes very shortly overall what you did, what you found, and also, if you want, you can also talk about the future directions. And conferences all have their own deadlines and their own criteria. So generally, you want to have a quick look at exactly what they're asking about because they have different structures and different word counts. And also, it's useful to just look at other existing abstracts that are well structured and good as reference. And then looking at the discussions, you then want to essentially synthesize information from other literature into the key topics that you're trying to cover. That way you can compare across what you found as to what they found. And if they do seem different, then you want to look at why this is, kind of try and find out if there's any reasons for it. And it's also good to look at limitations in your own paper. Essentially, that it's very good scientific practice to acknowledge what has perhaps not been as good as possible in your own paper, and it would actually be to the detriment and look quite dodgy if you didn't acknowledge any limitations, and it increases your credibility. I will say, like, you don't need to absolutely destroy your own piece of research, but it's very good to at least acknowledge the basic limitations that you have encountered. Um, and then you can also have a risk of bias if you'd like. Essentially, this will be like a table which shows the 7 criteria, usually has 7 criteria, and you can kind of give it a color scheme to show how at risk of bias each piece of literature that you used in your systematic review is. Which risk of bias tool you use will depend on what type of studies you generally look at in your systematic review. For example, randomized controlled trials use a tool called Robbins 1, but you should be able to research this online quite easily of what kind of tool you should be using. And finally, this is a process that you should probably be actually aiming to do early on in your project. But essentially, it's very important that you find a supervisor for your project and also consider the timeline you'd like to do this over. In terms of who to contact, you generally want to find someone who's in that field that you're looking for, who's got an obvious interest in the topic, as well as also having a relatively decent research output, just so that you know that they're quite into research as well. You obviously also want them to be available to contact, as you want to ask them questions and give a bit of guidance, just so they can tell you a bit more about exactly what you're looking for and wanting to do. Since they got that expert opinion. However, it's worth bearing in mind that doctors tend to be extremely busy, so there's not really any guarantee that you'll have regular contact and or be able to ask them too many questions. So this will still be quite an independent project, but I think it's quite worth developing these skills anyway. And also to submit to any conferences or to try and get a publication, it requires a supervisor anyway, so you still need to find one. In terms of how long this process takes, I'd say ideally you'd like to cover it over a year. You can spend longer, but it's quite important to bear in mind that the longer you take, the higher the chance that either other people will cover your topic as well as it's not been published yet, or new studies will be published in that meantime, which you won't have covered in your analysis of the review. And you don't want that because then that would make your review also out of date already before it's even published. So in theory, me and Rishi found that the actual creation of our systematic review can be done in about like 1 to 2 months, if you really set aside like as much time as possible for it. However, we understand that obviously you have a lot of things going on in your life, so perhaps you can take this might take a bit longer and over a longer period of time. Um, so yeah. But overall, I think that it's a really worthwhile process. And ultimately it's really achievable as well. I think that don't get bogged down by negative experiences, or if it doesn't work out the first time, as you have plenty of opportunities to do it once you've figured out how to properly do one. Hopefully this session's been helpful. So thank you very much for listening, and we're happy to take any questions if you guys have any.